For over 4 decades, the relationship between a player and their games was brutally simple. You bought a machine once, you slid a physical piece of media into a slot, and you owned that experience indefinitely. The actual physics of the game, the processing, the rendering, the logic, happened right there on the floor, directly beneath your television. Different model, called gaming as a service. The strategy relies on convincing consumers that maintaining this expensive, locally owned hardware is an obsolete practice. Instead of selling bulky consoles, companies are directing players toward thin clients. These are everyday devices you already own: smart TVs, cell phones, and lightweight laptops, now marketed as portals capable of running the most demanding, high-end titles available.
But the hardware in your hands is doing very little of the work. These thin clients lack meaningful processing power. They are empty shells waiting to be told what to display. The actual computing engine has been physically extracted from your living room and relocated thousands of miles away to remote data centers. Your personal device has simply been demoted to a very long-distance remote control for a corporate-owned machine. Operating a machine from that distance requires a complex, multi-stage serial pipeline. When you press a button to jump or shoot, that physical input has to be captured, translated into data, and routed through miles of public internet infrastructure to reach the server farm. Once the signal arrives, a distant graphics processing unit has to register the command, calculate the game logic, render a brand new high-definition 3D frame, and then encode that frame into a highly compressed video stream. This timeline charts what engineers call motion-to-photon latency. It is the total elapsed time from your physical input to the moment the corresponding pixel changes on your display. To trick the human brain into feeling immersed and responsive, this entire round-trip pipeline has to finish in under 100 milliseconds. Let's look closer at how that time budget is spent. The initial network uplink eats into the clock based on your distance to the server. Then, the server-side processing, the rendering and video encoding, consumes another large fraction of those available milliseconds. That leaves a shrinking window for the return trip. The heavy video file has to travel back over the internet downlink, be unpacked and decoded by your local device, and physically scanned out onto your monitor, all before that 100-millisecond deadline expires. This is an entirely different technical challenge than streaming a movie on Netflix. A video platform can seamlessly hide internet fluctuations by pre-buffering 30 seconds of footage in the background. Because a video game reacts to your inputs in real time, it has absolutely zero capacity to buffer. That creates an incredibly fragile tether. If your local network experiences a momentary spike in traffic, or if you live in a rural area with aging copper wiring, the data stream breaks down. You immediately experience unresponsive controls, severe input lag, and a screen full of artifacts. To mitigate this, tech corporations are spending billions on edge computing. They are physically installing smaller servers in regional hubs and utilizing 5G cellular networks, trying to push the processing hardware geographically closer to the end user. But no amount of investment can outpace the speed of light. Even with servers stationed a few towns over, your ability to play a game is entirely dependent on the quality of your regional infrastructure, rather than your personal skill or the hardware you bought. So why endure the massive costs and technical headaches of fighting the laws of physics? The answer lies in the business model. The industry is highly motivated to move consumers away from paying $70 once for a retail game they can keep forever. Cloud gaming offers what developers call frictionless entry. When a user can click a link on social media and start playing immediately, without waiting for a 100-gigabyte download, the conversion rate for impulsive in-game microtransactions rises significantly. The ultimate goal is to replace one-time physical ownership with an ongoing monthly subscription. Instead of a transaction that ends at the cash register, players are absorbed into a continuous revenue stream. We are already seeing the practical limits of this rented access. NVIDIA's GeForce Now, a major cloud platform, recently instituted a strict cap on playtime, limiting users to exactly 100 hours of gaming per month on their servers. If you want more time, you have to pay. Beyond playtime limits, the cloud model requires users to surrender their digital sovereignty. When a game is hosted entirely on a remote server, publishers have the absolute power to alter the code, inject advertisements, or completely delist a title from the library without your consent. We know exactly what happens when the servers turn off. When Google ultimately shut down its Stadia cloud gaming service, players lost their entire purchased libraries. Hundreds of hours of saved progress, unlocked achievements, and digital items were wiped out overnight. This is the reality of the infinite rent model. The convenience of frictionless play and hardware-agnostic access requires trading away your ownership. The second your subscription lapses or a corporate division misses its quarterly targets, the data valve closes and your digital library goes dark.